to our channel, The Classroom. Today I am back with the rational number, the last class. This is the third class, and we are going to finish with class 8 as well as 9 some extra topics of rational numbers. So till last day we have finished in number line. I asked you that if anyone has any doubts, please you can comment in it. Okay? Anyway, from today, again, as I'm starting with the rational numbers again, I'll be starting with the insertion of numbers within two rational numbers. Okay, so I think that will be an interesting topic again for you. So let's get started. So the first process is arithmetic mean method. Arithmetic mean method. This method can also be known as average. Okay, by the way you find out the average of two numbers. Okay, so let us consider any two numbers, like let us find out two rational numbers between 1.5 and 1/3. 1/2 and 1/3. Okay, we will find two rational numbers between 1/2 and 1/3. Okay, so let's come to it using the arithmetic mean method. Now 1/2 plus 1/3 divided by whole divided by 2. This is the particular formula. You know average also. Suppose A and B is given. So what is the average of A and B? It is A plus B by 2. That is what I have done. A plus B by 2. Okay. So we get the answer as, you know this LCM is 6. So it is 3 plus 2 whole divided by 2. So we get 5 by 6 divided by 2. That is 5 by 6 into 1 by 2. We get 5 by 12. Okay, so one of the number we have got. So 1/2 and 1/3, right? So one of the number we have got, that is 5 by 12. Okay, so what is the other number? Let's find out. This is it. Suppose this one. Okay, or maybe this one. Here I have said 2. Let me take, if I am taking 3, so accordingly you will find out. So if I want this number, okay, in between half and 5 by 12. So I am going to find out the mean of these two numbers. That means 1/2 plus 5 by 12 whole divided by 2. So you get, this is 12, 2 6 and this is 5 whole divided by 2. That means 11 by 12 by 2. So you get 11 by 24. So this number that you are having, it is 11 by 24. If you need this particular number, then you are going to add 5 by 12 with 1/3 whole divided by 2. Okay, so if you get that, you are getting 12, 5 plus 4 by 2. That means you are getting 9 by 24. This will be your answer. Okay, I hope I am clear to you. When you are going to find out between this middle term and 1/2, you are going to add this 2 and divide it by 2. And when you are going to find out this middle term and this term, you are going to add this 2 and divide by 2. Okay, then as you have got this as 9 by 24, again you can find out this particular term by 9 plus by 24 plus 1/3 divide by 2. So this is how you are going to find it out. Any number of terms. But yes, what is the thing is, it is a longer process, because adding and then dividing, this is a long root process. Okay, so for less, when we are just going to find out 1 or 2 rational numbers, or max to max 3 rational numbers, we try to follow this rule. Okay, because it is exact and it is accurate also. So but for suppose you are going to get a question where it is said that you are going to find 11 rational numbers. So if you follow this process, it is going to take a lot of time and it is simply a wastage of time. So that is why we have a very easy and shortcut process also. Okay, the next process, I am going to show you that too. So this is a long root process but is accurate. This process is arithmetic mean method. Okay, so this is whenever you are having a question where you need to find out only 2 or 3, then you can easily find it out. Next, coming up with the second method. Second method, okay? Second method is by LCM. Same question, suppose I'm going to find six rational numbers between 1/2 and 1/3. Okay, we have to find 6 rational numbers between 1/2 and 1/3. So what is the LCM method? First, as we are saying LCM, that means obviously we will be finding out the LCM of 2 and 3. So LCM of 2 and 3 is how much? 6, right? So we have done that comparison method. I think you have seen the first class. Yes, I want to say something that if someone has missed, because rational number, this is the middle portion, okay, or rather you can say almost the last portion. So I have already done 2 more classes of rational numbers. So if anyone has missed those 2 classes, there will you can click in this I button and you can get those 2 videos. Okay, so it's better just follow this, or you can follow the previous video just for this comparison. Now this is 1/2 and it is 1/3. Okay, now we need to find out, we need to get the denominator as 6. Okay, I have said this before also. So for that we need to multiply with what number so that we will get 6? 2, if we divide 6 divided by 2 will give you 3. That means we have to divide with 3 in the numerator and the denominator. So you're getting 3/6. Again, this we are having 6 divided 3 is 2. That means we have to multiply the denominator and the numerator with 2. That means you're having 2/6. So 3/6 and 2/6. Okay, I'm not going for any comparison now that to say that 1/2 is greater than 1/3. No. Right now I'm going to move on with this finding out the rational numbers in between 1/2 and 1/3. So these are the 2 values that we have got. Now, how many rational numbers do we have to find? 6, right? So whenever we have 6 rational numbers to be found out, we will take 6 plus 1, 7. Okay, we will consider as 6 plus 1, 7 and multiply with these numbers that we have got. Okay, so that means 3/6 into 7, down also 7. Means we will be multiplying the numerator and the denominator with 7. How did we get 7? I said 6, we need to find 6 rational numbers. That is why 6 plus 1 we are going to claim as 7. Okay, so 3 into 7, 6 into 7. So you are getting 21/42. Okay, check for here also. We have got 2/6. So 2/6 into 7/7. So you are having 14/42. Right? These are the 2 numbers that we have got, 21/42 and 14/42. So how many numbers are we going to get now? 6, right? So after 14, we are going to consider the numbers in between 14 and 21. Okay, so it is denominators all will be 42. I have mentioned it as 21. Now, I hope this is correct now. So, the rational numbers between 1 and 2 and 1/3, the 6 numbers are 15/42, 16/42, 17/42, 18/42, 19/42 and 20/42. Suppose here it was asked 10 rational numbers. So what was the number that we have to consider? 10 plus 1, 11. Okay, whatever number of rational numbers we want, we are going to add plus 1 to it. We need 20 rational numbers. So 20 plus 1, 21. And then multiply 21 in the numerator and denominator and get the following numbers. I hope I'm very clear with this. Right? Next, coming up with, so these 2 methods I think was very clear to you, right? Now this was the first one that we did was arithmetic mean method. Whenever, I'll repeat once more, if you're given only find out 2 or 3 rational numbers between any two particular given rational numbers, then use that arithmetic mean method. If you are asked to find out 10 or 11 or 12, then simply find out through this LCM method, where just remember one thing that is important. Whenever you are asked after that doing the LCM part and making before the comparison part of the rational numbers, remember that whatever number of that is rational numbers you have to find out, add 1 to it. If you are asked 15 plus 1, 16. 16 you are going to multiply in the numerator and denominator of the comparison numbers and find it. Okay, you can just see the last step, so that is a last sum, so that you can understand easily. It won't be a problem. Just remember, you need to add plus 1 to that number of numbers, rational numbers that we are going to find. Okay, so coming to the next part again. Now the next part that we are going to dealing with is recurring decimal. Now you might be wondering, what is a recurring decimal? Now there is a difference between recurring and non-recurring decimal. Recurring decimal are the one which repeats itself, okay, and the non-recurring ones are the ones which does not repeats itself. Now before coming to this recurring and non-recurring one, I'll say one more thing, that is we have terminating decimal. Now what is a terminating decimal? That is after the decimal point, if the digits come to an end. Okay, so that type of rational numbers will have terminating decimal. For example, 2 by 5. So divide 5 divided by 2, sorry, 2 divided by 5, you will get 5, give a point here, 0 comes down, 4, 20. So what is the answer of this 2 by 5? That is 0.4. Okay, you can see that after a decimal, this digit has come to an end. Okay, so this is what is your terminating decimal. You can take many more examples like this, like 3 by 4. Now 4 is dividing 3.0, 7s are 28, 2, 0 comes here because of the point, 5, 20. See what is the answer of 3 by 4? That is 0.75. 0.75, right? So this is again a terminating decimal. That is after the decimal, after 1 or 2 digits or 3 digits, the digits will come to an end. Okay, so that is the remainder will become 0. So these are terminating decimals. Now coming to non-terminating decimals. Now what are non-terminating decimals? Now within this non-terminating decimal, there will be two things. One will be non-terminating recurring decimals, non-terminating non-recurring decimals. Okay, non-terminating recurring decimals, non-terminating non-recurring decimals. Now recurring, as I said, means repeating, and non-recurring means which does not repeats. Okay, so examples of non-terminating recurring decimal. Now non-terminating, before this we studied about terminating decimals, where we said that after the decimal point we have that the digits will come to an end. But for this non-terminating decimals, it is that after the point, that is after the decimal, the digits does not comes to an end. Okay, so here let us take the example of 1 by 3. So we have 3 is dividing 1.0, 3 3s are 9, 1, then again 3, 0 comes down, 9, again 3. And see, like this it will continue. Okay, so answer of this becomes 0.333 and dot dot. So whenever this particular 3 is repeating itself so many times, we call that as recurring decimal. The number which repeats itself continuously, or the numbers which continuously repeats itself after an interval of time. Okay, so that is known as recurring decimals. Okay, non-terminating because it's never going to end. Non-terminating meaning which does not have an end. It is not going to end and it is going to continue with the same digit. In that case, since this 3 is particularly repeating itself so many times, we can write in the 3 in this way. Either put a bar above the 3 or we can write to 0.3 1 dot above the 3. Either 3 a bar above it or 0.3 a point over it. Over the digit which it's repeating. Over the digit which is repeating. Please remember. Okay, over the digit which is repeating. So this is an example of non-terminating recurring decimal. Next, coming to non-terminating non-recurring decimal. These are the examples of root 2, okay, and so on. We have 1.414, then dot dot dot. These all are non-recurring decimals because these values does not match any one of them. Okay, so it continuously goes on increasing. So any value of root 2, root 3, all these are 1.732 and then dot dot. All the digits are different in these cases. Okay, so those are non-terminating and non-repeating digits, decimals. Okay, so these are for these values, root 2, root 3, root 5 and so on. Okay, which does not have any fixed value. Okay, so this is the difference between non-terminating and terminating decimals. Terminating decimal I have shown before only, non-terminating, two types I have shown, recurring and non-recurring decimals. I hope till here it is clear. Now we will come to the last part, that is we have already done till here rational numbers. We are just going to proceed or say something about irrational numbers also, otherwise it is incomplete. Now this irrational number and the next part which I am saying, it is not there in class 8 but is there in class 9. Okay, I am going to say whatever from here, this part that is there in class 9 but not in class 8, and till 7 also. Till here whatever I have taught, class 7 is having these. Okay, for the chapter rational numbers. Now this part is only for class 9, so those who want to have, ask questions, you can write in the comment section from this part. Okay, I think the other parts will be very clear to you because you already have done in class 7 and 8. Anyway, so coming to the next part, irrational numbers. Irrational numbers. Now, irrational numbers are numbers which are also expressed in the form p by q, where q equal to, that is q can be equal to 0. For rational numbers we have seen p by q where q cannot be ever equal to 0, but here it can be 0. That means if a number, if a digit is divided by 0, we will get undefined, right? We will not have any proper value for it. So that is what is irrational numbers. Irrational numbers are the numbers which does not have any significant, that is a value of any particular rational numbers. Okay, like root 3, 1 by root 5, all these are examples. Root 2, 1 by root 5, 3 root 7. All these are examples of irrational numbers which does not, where we does not get any proper value for these numbers. Okay, so this is what is irrational number. Okay, now going to the last part of the rational numbers, that is how to rationalize a rational number. Okay, let's get started with it. Before we start saying the last portion, that is rationalizing the rational numbers, I just want to discuss with you another point, that is how to convert a decimal into a proper rational number. How to convert a decimal into a proper rational number. Now let's take for example, suppose we have done suppose 0.333 and there is a bar over here. That means this particular 3 is repeating itself. You might know the answer for this. Anyway, which is the method of like finding out a decimal to a rational number. Now you have to consider this particular number as x, 0.033 3 bar. Okay, there's not a point, nothing like that. Okay, let us consider this as x. Now multiply both the sides, multiplying both the sides with 10. Okay, so we get what? 10 into x equal to 0.333 bar, that is 10 into 0.333 bar. Okay, so we get 10x, that is equal to 3.33 bar, right? So let us consider this as equation 1. Okay, again you can also do this, or you can simply mark this as equation 2 and solve it out. Don't need to actually. So you can simply do one thing, take this as equation 2, because see, this whole 3, you can also put this, you don't need to write this, you can simply write this 3 and put a bar, because you know already that this is the only digit which is repeating itself. So you can simply write this also. Okay, so this only you can keep it as equation 1. Okay, so equating equation 1 and 2, see what you are getting. Suppose this minus this we will be doing. Okay, so that means, sorry, 2 minus 1 we will be doing. 2 minus 1. Okay, equation 2 minus 1. So that in that case you will get what? 10x minus x, 3.3 bar, suppose I'm wiping out 1 3 from here, so minus 0.3 bar, because this 3 bar or 3 bar both are same, so you are getting here 3.0, you can write if you want to. So this is coming to 9x is equal to 3, so x equal to 3 by 9. 3 1s are 3, 3 3s are, so 1 by 3. So x is equal to 1 by 3. So whose decimal number was 0.3 bar. Okay, you can also write 0.3 bar, anyone. Okay, so this was an example of how to convert decimal to rational number. Okay, so let's take another example. Suppose it is 0.8823 and this 3 is going to repeat. Okay, 82 is not repeating, it is only the 3 that is going to repeat. So let us take this as x equal to 0.823 bar, right? Now this is coming to, let's multiplying by 10 on both sides, we get 10 into x, that is equal to 10 into 0.823 bar. It is coming to 10x equal to 10 means one digit it will go on the right hand side, means 8.23 bar, right? Now next, equation 1 by 10, we get 100x, right? I'm directly writing. It is going to be coming 82.3 bar. So you are getting this as equation 2. If you subtract this 2 is still remaining on the side. Always remember that after the decimal point we are going to keep the digits which are repeating itself. Okay, remember one more thing, that is what I am saying. Please listen to me carefully, that whenever we are after the decimal point, we are only going to keep the digits which are repeating itself. Okay, the recurring digits, not the other digits. Other digits all we will move toward the left hand side of the decimal point. points. But on the right hand side of the decimal point, it is only after the multiplication of 10 or 100,000, whatever is required, only the recurring, that is the digits which are repeating itself, we will keep only that. Okay, so here if we subtract, there is going to be a problem again. So let's do one thing, let us multiply by 10 once more. So multiplying equation 1 by 100, okay, we get, equation 1 means this one, so we get here 1000x equal to 823.3 bar, that is equal to equation number 3. Okay, so see, we have only the recurring digits here on the right hand side of the decimal. So this is what our need was. We will keep only the recurring digits, that is the repeating digits after the decimal point. Okay, so equating equation 3 and 2, we get what? 3 and 2. So that means 1000x minus 100x will give you 823.3 bar minus 82.3 bar, right? So you are getting here 900x, right? Equal to, this is going to be your 0.0, 1, 9, 10, 11, 12, 4, 1 here, 741. So x is equal to 741 by 900. So this is your answer. Maybe it will not get cut or something like that, okay, but this, or maybe it is a huge number with something, maybe 21 or something, it may get cut, but doesn't matter. You can keep that in that way. Okay, so this is the answer for converted, that is, its decimal point was 0.823333 and so on. Okay, by looking at this step you can easily understand, and please remember that after the decimal point we are only going to keep the repeating digits and not any other digits. The other digits will go to the right hand and left hand side of the decimal. Okay, that is what we have done in these two steps. Okay, that is from equation 1 we have done 100, that is multiplied by 10x to move all the other digits to the left hand side, and just to receive that again we have done this 1000x over here. Okay, so that we get this particular number, we can subtract this too, and so that we can only have them. Our main motto was to have that after the right hand side of the decimal we must be having only the recurring digits. That's what we have done. Okay, I think I'm clear to it. Next, coming to the rationalizing of the rational numbers. Okay, I'm rubbing all this now. Next, as I have told you before that this is the last portion, the first that we are going to come is, suppose a number is given 2 by root 5. Okay, so how you are going to convert that into we know the word rationalizing, right? This number will be multiplied in the denominator and the numerator. We have to see that the denominator comes a normal digit, not a irrational number. So we are going to get 2 root 5 by 5. So this is how we convert the numbers or rationalize the numbers into rational numbers. Rationalizing means the denominator should be a normal of the irrational numbers. Now, this is one such example. Another one example is, suppose we are going to have 2 minus root 5 as a number. We are going to rationalize it. How to rationalize? We will be multiplying this particular number with the opposite sign. Okay, the same number with the opposite sign. So we get here, this is formula of a minus b and a plus b, right? So we will get here, that means the answer will be a square minus b square. So applying the algebraic formula a minus b and a plus b, we get here 2 whole square minus root 5 whole square. Okay, so we get here 4 minus 5, that is equal to minus 1. So our answer is minus 1. Now this is another example how to convert that or rationalize that. Same thing as I said, we will be multiplying the numerator and the denominator with this particular digits, okay, this particular digits, but with the opposite sign, So we are going to have root 3 minus root 2 by root 3 minus root 2. Okay, so here we are going to get root 3 minus root 2. You can see here minus this particular one and this particular thing, both are equal. So that means we can write in the a minus b whole square form by, this is a plus b, a minus b, same formula. So we can write root 3 whole square minus root 2 whole square. Okay, so you're going to get here, this you have to x, that is you have to break these. Okay, so simplify. So root 3 whole square, a square minus b, a minus b whole square, minus 2ab plus b square by, this is root 3 means, whole square means 3 minus 2. So you're getting here 3 minus 2 into, this is root 6 plus 2 by 1. So you get here 5 minus 2 root 6. So this is your answer. So this is your answer for this expression. This is how we rationalize. Okay, that is the simplest form that we have received. This is one of the sum. Okay, now separately we have to solve these. So let's take this first portion, that is 22 by 2 root 3 plus 1. As you can see, we are having plus 1 over here. That means we are going to multiply the numerator and denominator with the opposite sign. That means 2 root 3 minus 1 by 2 root 3 minus 1, because our intention is to rationalize the denominator first. So this is going to be 22 into 2 root 3 minus 1 by, this is again a minus b, a plus b formula. So 2 root 3 whole square minus 1 whole square. So we are going to get 44 root 3 minus 22 divided by, this is coming to 4 into 3, that is 12 minus 1. So we are having 44 root 3 minus 22 by 12 minus 1. So we are having this as, I'm writing this side, you can understand hopefully. So this 22 also you can keep it outside, so that this is going to cut with 2. You are going to get 4 root 3 minus 2. This is the answer. Okay, so after this I am here. Okay, so I think from this you can understand. Next part, we are going to have the 17 by 2 root 3 minus 1 into 2 root 3 plus 1 by 2 root 3 plus 1. We are going to have 17 2 root 3 plus 1 divided by, this is going to come 12 minus 1. So we are having 17 2 root 3 plus 1 by 11. Okay. Now the two results that you have got, this is the first result and this is the second result. As per the answer of this is this one, 4 root 3 minus 2, and the answer of the second part, 17 by 2 root 3 minus 1, is this. So we're going to add these two results. It's going to come 2√3 plus 1 by 11. Now this is going to be, taking the LCM as 11, we are going to get 44√3 minus 22 plus 34√3 plus 17. So we are having this as 78√3 minus 5 by 11. So this is your answer. Just what we need to know is how to rationalize, and remember that during the rationalization you have to always take the opposite sign. Okay, so this was what was about the last portion, that is going to be of class 9. Okay, class 8 is not having this particular rationalization. This was only the portion of class 9. So next day again we'll be coming up with a different chapter. Till then, if you are going through the videos, if you're having any problem, please do comment over there. And if you obviously like it, please like, share and obviously subscribe. Thank you.